Let's compare the two types of bonding we're going to talk about in class, ionic and covalent. For both bondings, the electrons that are involved are the valence electrons, or the outermost electrons. In ionic bonding, there exists ions in the bonding. These ions occur because the metals on the left-hand side of the periodic table lose electrons, forming a cation or a positive charge. The nonmetals then gain the electrons, forming an anion or a negative charge. And the attraction between the positive metal ion and the negative nonmetal ion creates the ionic bond. So in the ionic bond, we say the electrons are transferred. By looking at a formula of a compound, we can often tell if it's what type of bonding it's going to be, and ionic bonds contain metals and nonmetals. In covalent bonds, the valence electrons are not transferred, but they're shared. So two atoms will share the electrons between them. This occurs when in the sides of the nonmetals together. It would also occur up between a metalloid and a nonmetal. This sharing of the electrons is what creates the bond in covalent bonding. Covalent bonds do not create or have ions in them. Instead, they form units that we call molecules. Now, looking at the types of elements, you'll notice I don't have anything that says metals and metals. That's a different type of bonding called metallic bonding that we're not going to be talking about in this class. So one takeaway from this is oftentimes by looking at the formula of a compound, you can tell the type of bonding that you would expect based on the types of elements. So metals and nonmetals would form ionic bonds. We know they have ions inside of them, and they occur because the valence electrons have been transferred. In nonmetals, if the formula has nonmetals, then we know that that's a covalent molecule, and those electrons in that molecule are shared. Both ionic and covalent bonds, we can predict how they'll bond or their patterns of bonding using something called the Octet Rule, which I'll mention when we talk about each specific type of bonding.